We're going to look at transformations of functions. Our parent function for a quadratic is x squared. So we're going to look and see what happens when we add numbers to our function. So I want to see what happens when we have x squared plus 2. Then let's look at x squared plus 6. It's moving up. So if we do the same thing, but instead of adding a number, we subtract it. It goes down. And that's going to happen the whole way down. So when we add something or subtract something to the end of our parent function, we call this a vertical transformation, a vertical shift. So now we're going to look and see at what happens when we add something to x squared, but now inside the exponent. So we're going to have in parentheses x plus 3 and then square it on the outside. So all I've done is inside with my x, with the exponent, we're adding numbers. So let's do another one of those. X plus 5 and then square it. So right now it's moving to the left. Well, what if we do this but we subtract the values? So subtract a 5 and we subtract a 3. It's still on the horizontal, but it's now going to the right. So we call this a horizontal shift or horizontal translation. So let's go back to our parent function. What happens if we put a number in front? We've done with the x, we've done behind the x, but what if we do a number in front of the x? So I'm going to put a 2 there. Alright, well let's look and see what happens if we put a 5 there. And maybe a 10. It starts to stretch vertically. Let's do the opposite. Let's do 1/2. 1 divided by 2 out in front. So that one went out. Let's see if we make it 1/8. What happens? So this we call a vertical shrink or stretch. When we use whole numbers, numbers greater than 1, they don't have to be whole numbers. When we use numbers greater than 1, it stretches vertically. When we use numbers less than 1, it shrinks vertically. So let's do one more thing. We had all of the numbers in front positive. So what happens if we make those numbers negative? Well, it reflects. We just call this a reflection. So this is what happens visually with the transformations of our parent function x squared. It will also work for other functions like a cubic function. If I were to take my cubic function and I were to add a number to it, it's going to move up and down. If I put it with my x, it would move it left and right. Let's look at a quartic function. It does the same thing. So transformations work for all polynomials. When looking at transformations of functions, specifically transformations of quadratic functions, we look at the vertex form formula. -a times x minus h squared plus k. We need to look and see what each piece of the formula is doing. So we look at h. H is our horizontal translation. It's what moves us left and right. K is our vertical translation, meaning it moves the function up and down. Then we have a, which is multiplying to the whole entire function. If a is greater than 1, it's a vertical stretch. If a is less than 1, it's a vertical shrink. And if there's a negative out in front, it means it reflects over the x-axis. When we look at our function f of x equals negative 2 times x minus 5 squared plus 7, we see that the negative sign reflects our function. The 2 stretches our function by 2, and then for h we always take the opposite sign since h is negative. So instead of a negative 5, we do a positive 5 going right 5, and then the 7 moves our function up 7. Now let's look at our other function. We have 1/2 times x plus 1 squared minus 9. So in this function, the half shrinks our function by 2. The 1, again, we do the opposite. So instead of plus 1, we do negative 1. So we're going left 1, and then we go down 9 from this point.